All right, this is section 7-6 part 2, and we are going to look at solving equations that already have a logarithm in them. So in the last video and lesson, we looked at equations where we had a variable in the exponent and we used a log to get the variable alone. And in these equations, we are already going to have a log present that we have to deal with. And so there's three scenarios we're going to look at. For how these work. And the first two are relatively straightforward, and the third one's a little bit more involved. So let's get started. So the first scenario is that you have a couple of logs and they cancel. And to show you what I mean, let's look at an example. So let's say that I have the log base 5 of 4x minus 7 equals the log base 5 of x plus 5. Now, at first glance, this looks really intimidating, but it's actually not so bad if we think about it a little. So we have an equal sign, and that means that the left side of this equation is exactly the same as the right side, right? They're exactly the same. So whatever's on the left must be the same as what's on the right. And what I notice is that they're already partly the same. They both have a log of 5. So if the two sides are exactly the same and they already have the log 5 the same, then it must be that the 4x minus 7 part has to be equal to the x plus 5 part. There's no other possibility. The left side equals the right side. The logs are already the same. Okay, so effectively I can cancel them, and if these two sides are to be equal, then the 4x minus 7 part and the x plus 5 part must also be the same, and then it's a minus x. It's a pretty easy solve. 3x minus 7 equals 5 plus 7 plus 7, so 3x equals 12, and x equals 4. Okay, just another quick example, another way to think about that. We'll call this one number 2. If I had the log base 4 of 2x plus 8 equals the log base 4 of 6x minus 12. Again, I've got the two sides equal, and you know that another way to think about this is that taking the log of both sides does not change the equation. In fact, we did that in yesterday's work, right? We took the log of the left and the log of the right. So I really don't need the logs at all, right? They effectively just cancel. And 2x plus 8 equals 6x minus 12. And I'll let you solve that one on your own to verify. X should equal 5 in this. You can check your work. But the idea is if I'm taking the log of both sides, those logs must cancel. All right, scenario 2 deals with the idea of there being only one log in the problem to begin with. And so an example of that would be, we'll call this one number 3. If I had the log base 4 of 5x minus 1 equals 3. Now there's only one log here, so I certainly cannot cancel the log, but this again looks challenging. It's really not, because even though I'm not exactly sure what to do with this, there is another form I can write it. And what I'm going to do is I'm going to put it in exponential form. Now, we know what exponential form looks like. If I have, log base 2 of, let's say, 8 equals 3, I know that this means that base 2 to the third power, right, equals 8. Exponential form, logarithmic form. And I'm going to do the same thing here. I'm going to say base 4 to the third power equals 5x minus 1. Gosh, I can solve that. 4 to the third is 64. And pretty easy solve. Plus 1, 65 equals 5x. And x ends up being 13. Exponential form. Okay, just real quick, one more kind of like this. If I did, call this one number 4. If I did log base 7 of 3x minus 2 That would be this. That would be 2. Okay, so log base 7 of 3x minus 2 equals 2, and I want to solve this. Again, I can go to exponential form because there's only one log, so it's pretty easy to do, right? Base 7 to the 2 power equals 3x minus 2. So 49 is 3x minus 2. Now I'll let you might want to try this, just verify your solution, but you should end up with x equals 17, but I know you know how to solve that. Okay, so putting it in exponential form is a good strategy. So in the first case, we had a log on both sides, and the logs were really just able to cancel because those left side and right side, those were equal to each other. So cancel, and see what I've got left. That's kind of like one of the techniques we learned about solving exponential equations. And here we only have one log, so a good strategy is to just put it in exponential form. Now, the third scenario we could see, this is probably the most challenging one. And in this case, well, let's look at an example here. I'm going to have two logs. So let's say I have the log of 2x, and we'll just do the common log, base 10, right? So I don't have to write the base, plus the log of x minus 5 equals 2. Now there's two logs here, so I might start to think about canceling them, but the problem with that is they're not on opposite sides of the equation. And you say, well, I could get them on opposite sides. Maybe I could minus the log here and put it over here, but then I still have that 2 to worry about, and so that sort of complicates things. So with this guy, I'm going to leverage the fact that I know about adding logs. Right? I know about adding logs because I have a property of logs we learned about. It said if I have the log of a times b, that's the log of a plus the log of b. Right? That was one when we were doing expanding and condensing. That was one of the 3 properties that we learned about. And so I know that I can take a plus 2 logs that are added and turn them into one log that's multiplied. So I'm going to condense this. So I'm going to have the log, but it's going to be 2x, right, that's this guy, times x minus 5. That's this guy, and of course this still equals 2. So I'm doing a condense step right here. Condense. Okay. Now let me simplify this a little bit because I do know that I can play the distributive property game here, right? So I still have the log, and 2x times x would be 2x squared, right? And 2x times negative 5 would be minus 10x, like such, and again, still equals 2. Now, because I have condensed this, right, now after condensing, there is only one log left. So now, this is kind of a scenario 2 problem, where I can put this in its exponential form. And right, it's log, we didn't write a base, so that means it's base 10. And in exponential form, we'd say base 10 to the 2 power equals 2x squared minus 10x. Okay, so we went to exponential form. Exponential, think about how to spell that there, exponential form. And at this point, we have no more logs, and we have some exponents, but they're not variables, they're 2, so life is good. But what you'll notice, and this is what makes this, kind of big kid math, so I said this third technique could be a little tough, is because I notice that we have a quadratic. Okay, and we spent a lot of time solving these first semester, and there's lots of techniques to solve quadratics, but my go-to strategy is factoring. So I'm going to get this in standard form, and getting it in standard form means I'm going to get it equal to 0. So I'm going to go minus, and 10 squared is really 100, so I'm going to say minus 100, minus 100. So I will now have 2x squared minus 10x minus 100 equals 0. Like such. Okay, so this right here is standard form. And now I'm going to try to factor it. Now when I factor it, if I look at the 3 terms, I notice that I can pull a 2 out of all of that. So I'm going to go ahead and do that and get x squared minus 5x minus 50 equals 0, like such. And now from here, my 2's still there. It's not really going to help me much, but I'm going to try to factor this into a couple of different things here. I know I'm probably going to have x and x, and I think by now most of you are pretty good at factoring. But I think I'm going to need a minus 10 and a plus 5. I think that's going to work out. And of course you can make your little t-chart and check and whatnot, but I'm pretty sure that the negative 10 and the 5, that's going to get me my negative 50. And I'm pretty sure those are going to combine to give me my negative 5 x in the middle. So from here, I can derive my solutions because I've got 1, 2, 3 things multiplied to get 0, which means one of them has to be 0. Well, 2 can't be 0, so I don't care about that. If x was a 10, I could get a 0 because 10 minus 10. And the other way I could get a 0 is if x was a negative 5. See a negative 5 right here. That would give me a 0. And 0 times anything is 0. So here's my 2 possible solutions. Now, as we've seen in other chapters, right, sometimes, my problem didn't start out as a quadratic. But in the process of solving it, I made it a quadratic. So there is a potential that these solutions could be extraneous. So we do need to check our solutions. And I know that's kind of a pain in the butt, but it is possible that one of these two is extraneous. So we'll finish up here by checking these just to show you and convince you that these might not always work. So our original problem, we had log of 2x plus log of x plus 5, or x minus 5, sorry, equals 2. And if we plug in our first solution, 10, so we'll do that, log of 2 times 10 plus log of 10 minus 5 equals 2. So we end up with, if we simplify, we get log of 2 times 10, log of 20, plus log 10 minus 5 is 5, right, equals 2. Let me condense this, right, because I can condense the add right here and get log of 20 times 5, log of 100 equals 2. And remember, it's log base 10, and let's see, is this true? 10 squared is 100? Yup, solution checks out, life is good. Okay, let me do the same thing for the other one here. So the other possible solution we came up with was negative 5. So log of 2 times negative 5 plus log of negative 5 minus 5 equals 2. And here I'm going to get log of negative 10 plus log of negative 10 equals 2. Now right here I can pretty much tell you that it's not a solution because I'm pretty sure we can't take the log of a negative number. And the reason I know that is that the log base 10 of negative 10 says, what power do I raise 10 to get a negative 10? And I know that there are no powers that give me negative answers, right? 10 to the negative 1 is not negative 10. 10 to the negative 1 is 1 over 10. And so it turns out, because there are no powers that give you negative numbers, this right here is going to be extraneous. So negative 5 is extraneous. And again, I know that because if I was to input it and get a negative, if I would be taking the log of a negative number, I can't do that. So negative 5 is extraneous. My only solution is 10. Okay, my only solution is 10 because I can't take the log of a negative number. So, and again, we could test this out. You could type it in on your calculator. If you tried to type this in on your calculator, it would actually give you an error, and that would be another way to clue yourself in. So this last scenario can be kind of challenging because it throws in some stuff that we did first semester, but it's definitely something you can do. If you want to get it right, though, on a test, you are going to have to practice it. So that's it. And I will see you in class. If you have questions, please let me know, and you'll get the chance to practice this tomorrow.